Hello everyone, welcome to Advanced Maths 101. Today is day 3, 13th May 2024. Here we have two questions. The very first question is if A1, A2 and this goes to AN is a sequence of positive numbers which are in AP with common difference D, and this is given, this is given, and this is given. It is saying that maximum value of the product of all the A, A1 to A16 is equal to S upon W raised to 16. Okay, where S and W are co-prime. Then we need to figure out what are the possible options that matters. So let's first write the given informations. A7, and I think it will go to A10, then A13, then A16, and this is equal to 147. So say we have this first term to be A1 only, and since the common difference is D, so let me write 3, 6, 9, 12, 15. These are the D values where it will be given. So we will have 3 plus 3, 6 A1 plus 3 plus 6, 9, 9 and 18, 30, 45. 45D is equal to 146. Okay. And now we have A1 plus 15D is equal to N. And what's that? 2A1 plus 15D equal to capital N. Okay. And we have this A1 plus A6 plus A11 plus A16 equal to N. So again 0, 5, 10, 15. These are the D values, right? And since we have four terms, so 4A1 plus how much? It will be 30D equal to N. Okay. So we have this thing, the very first equation. We have this and we have this. Okay. If you look closely, you will observe that on dividing the very first equation by 3, we will get this. So M value will be how much? 147 by 3. So it's what? 449. And if you observe that, then multiplying the second equation by 2, you will get the third equation. So n value will be how much? Twice of m, that is 49. So that is 98. So we have n equal to 49, n equal to 98. Okay. Now we need to think about s and w. Yeah. So we have this term a1, a2, a3, a16, and this is equal to s by w times 60, and it is given the maximum value. Okay, right? Maximum value. Also given that all AIs are positive numbers. Okay. If all AIs are positive numbers, and we need to find the maximum of product, so one thing that must strike A and G inequality. So it says that summation of all the AIs A16, since there are 16 terms, this will be greater than equal to A1, A2, A16, this. Okay. So if you write this, we need to find its maximum value. So its maximum value will be how much? This term that is given over here is always lesser than, it is always lesser than equal to this. So its maximum value will be this only, right? The maximum value of this will hold when the equality hold. Okay. So what we have, the summation of A1 to A16, we can write it to be how much? There are like 16 terms, okay, and divided by 2. And we have this information that A1 plus A16 to be n. So A1 plus A16. So what we can do, and we have this value 49. This thing equal to by 16, okay, and we have this symbol greater than equal to this a1 a2 dot a16 raised to 1 over 6. Taking this power on the RHS side, first cancel this. So we have 49 by 2 raised to 16 greater than this term, say this to be alpha. So we have the maximum value of alpha max will be how much? 49 by 2 upon raised to 16. And when this will hold like you must know that in AMGM inequality, equality hold for when all these terms, all these are equal. So I mean to say that it will be A1 equal to A2 equal to A3 uh, equal to A16. These all terms will be equal. Then only we will get the maximum value. Since in this question there is no relevancy of this term, but yeah, you need to see one thing that whenever we are equating the maximum value, like for maximum value, we are using the equal to term, not the lesser than term. So we need to have in mind that all the numbers, all the terms that we are using must be equal. So what we get from over here that alpha max is equal to 49 by 2 raised to 16. So on seeing that S is 49, right, and W is 2. So here we have A, B, C, D. All the options are correct. So moving on to next question, we have this question. This says that the smallest positive integral value of A for which the greater root of this expression, this quadratic, lies between the roots of the equation this. So we have two quadratic equations and we are given about we need to find about the roots. So first write the equation one. It is this thing only a into a square plus. If you observe it that you must notice by splitting the middle term that we can factor it easily. It will be how much? It will be a square plus 1x minus ax plus a into a square plus 1 equal to 0. And we get that a square plus 1 into x minus a equal to 0. So what are the factors of this? Factor will be x equal to a square plus 1 and x equal to a. So we have these two factors and the greater root. So greater root will be this only because on a squaring we are squaring it and adding one to it, right? So the greater root will be this one. And it is also given that the positive integral value of a. So a is a positive integer, a is an integer, right? And if we are squaring it and adding on, so this will be greater. A square plus 1 is a greater term. So we need to figure out that uh, for what value of a such that this root a square plus 1 lies in between the roots of this. So this equation number 2 that we have, its value, its coefficient of x square is positive, right? And since they are saying that between the roots, so we will have the graph of this second quadratic will be like this, right? Root 1 will be over here and root 2 will be over here. So this is alpha, this is beta. And we are saying that uh, the root of the first quadratic, that is a square plus 1, it lies in between. So say here it lies. So if you put the value of x to be a square plus 1, so you can clearly see that what we will get, like this is our x-axis and somewhere there will be y-axis. I'm not drawing it. So value of y that is coming is negative. So if this is f of x, say, so on putting f of x equal to a square plus 1, what we get is negative number, right? We will get the negative value. So now let's do it. So putting the value of x equal to a square plus 1, we have a x square minus a square, and here we have x minus 2a square plus 4, and this will get negative. Okay. So on simplifying it, what we get, okay, so we have something cancelling up over here. A raised to 4, a raised to 4 cancel, 2a square will cancel. So what we will be left with, that a square is greater than equal to 5. And since it is given that a is a positive integer number, so if a is 2, the smallest it is also saying. So if a is 2, so what we will get, that 4 is greater than 5, but this cannot happen. So minimum value of a will be how much? 3, right? So we need to see that this a, we need to find that the smallest positive value of a for which the greater root of this lies between the roots of the equation we have done is less than. So we need to find basically that out of these four options which are less than 3, right? We need to find that no, not the no. We need to check for the options which are greater than this thing. Then only this term will be lesser than, right? So let me first draw the options, then I will explain. So here we have 27, again we have 27, and it goes. So on writing, what we have, this is 1 by 2 power, okay. Again, we are dividing by this term. So it will be how much? This is like, say we write this to be root under 27, and this is going up to 1 by 2. So on this term, what power we will get? It will be how much? 27 1 by 2, and since there it is 1 by 2, so it will get to this also and this also. So we will be having 1 by 4 power, and this is in denominator. So we will be subtracting, right? And again, the next number will be there, so it will get to numerator. See, if we have 5 by 3, and then we have 2 by say 4. So what we do? This goes over here and this goes over here, right? So the same thing I am doing over here. So the next power will be on the upper side, that will be on numerator side. So and it will be with how much power? It will be with 1 minus 8 power. Then again it will be, and the next number will be on the denominator and it will have 1 by 16 raised power. Then again 1 by 32, and this will goes to infinity. So you can see that this is what, this is an infinite GP, and we know the summation of infinity for infinite GP. So what it is? A minus 1 by R. So we have A over here, how much? 1 by 2, and R is how much? See, it is minus 1 by 2. So 1 minus 1 by 2. So what do we get from over here? That it is 3 by 2, 1 by 2. We get 1 by 3. So 27 raised to 1 by 3 is how much? It is 3. Okay. This is option number A. Let's first simplify the options again. Now we have this 4 raised to, like it is going 4 raised to 4 raised to, and this is going to infinity. So again, we have on this 4 number is how much power? It is 1 by 2. Again, on this number we have how much? We will basically 1 by 4, right? Then again on this number, how much power? 1 by 8. Why this 1 by 4, 1 by 8 it is going? Because this power is on this number also, right? And on this 4, we have this root and this root. So we have two roots, right? Okay. So again, it will go to infinity, and we know that in multiplication we have summation of powers. So it is also an infinite GP. From writing over here, simply it will be how much? It will be 1 by 2, and 1 minus 1 by 2 will be 1 by 2 only. So it is 4. Okay. So option number B is how much? It is 4. Okay. Now we need to check for the option number 3, and it is root under 5. Okay. Let me do it over here only. It is root under 5. Okay. Say right over 1 by 2. And on this 5 we have how much? It is this 1 by 2 and this 1 by 2. So we have 1 by 4. And on this 5 how much? It is this, this and this. So we have 3 roots. A square root basically. And again. So it will be also how much? It will be 5, right? And now for option number D, let's see. It says that root under 2 plus this. Okay. And say, so over here, let's say this number to be n. Let me do it on the x slide. So we have, and it is going to infinity. Say we have this number to be n. So on squaring it, what we get? We get this thing, and here we have n square. If you, since this is going to infinity, so taking 1 2 from outside will not change the value, right? So it will be also n only. So we will have n square minus n minus 2. So can we simplify n square minus 2n minus plus n minus 2. So we will get, yeah, we will left with this term. Okay. And this is equal to 0, right? Because this is equal to 0. So from over here we get n equal to 2 and n equal to minus 1. Minus 1 cannot be the value of n, because since the value of a square root that we will be getting, it will be a positive number, right? So minus 1 can be ignored. So value of n will be how much? 2. So we have this option number D to be 2, option number 4, option number B is how much? It is 4, and option number A is how much? 3. So now we need to solve the question. We have already figured out that value of A is how much? 3. So see carefully. The smallest positive integer value of A for which the greater root of the equation this lies between the root of equation this is less than. So means this 3 is less than which options? 3 is like I'm writing this A. So this A should be lesser than the options. So in option number A it is equal, so A cannot be answer. In option number B, option number B is greater, right? Then only A will be lesser than option number B, right? So B is correct. C is also correct. But option number D is lesser, so it will be not correct. So answer will be what? Here we will have answer to be option number B and C. So here we have option number A, B, C, D all are correct, and here we have option number B and C correct. Okay. See you tomorrow.